Hello guys! Today we'll speak about airframe. The goal of airplane designers and manufacturers is to obtain maximum efficiency combined with adequate strength. Excessive strength requires additional weight, which lowers the efficiency of the airplane by reducing its speed and the amount of useful load it can carry. Airframe means the fuselage, booms, nacelles, cowlings, fairings, airfoil surfaces, including rotors but excluding propellers and rotating airfoils of engines, and landing gear of an aircraft, and their accessories and controls. Airplane structure. The required structural strength is based on the intended use of the airplane. An airplane which is to be used for normal flying does not need the strength of an airplane which is intended to be used for acrobatic flight or other special purposes, some of which involve severe in-flight stresses. Numerous wing designs were developed in an effort to determine the best type for a specific purpose. Basically, all wings are similar to those used by the Wright brothers and other pioneers. Modifications have been made, however, to increase lifting capacity, reduce friction, increase structural strength, and generally improve flight characteristics. Airplane strength is measured basically by the total load which the wings are capable of carrying without permanent damage to the wing structure. The load imposed upon the wings depends upon the type of flight in which the airplane is engaged. The wing must support not only the weight of the airplane, but the additional loads caused during certain flight maneuvers, such as turns and pull-outs from dives. Turbulent air also creates additional loads, and these loads increase as the severity of the turbulence increases. The type of wing design for a particular airplane depends almost entirely on the purpose for which that airplane is to be used. If speed is the prime consideration, a tapered wing is more desirable than a rectangular wing, but a tapered wing with no twist has undesirable stall characteristics. Assuming equal wing area, the tapered wing produces less drag than the rectangular wing because there is less area at the tip of the tapered wing. The elliptical wing is more efficient, greater lift for the amount of drag, but does not have as good stall characteristics as the rectangular wing. Wing flaps. Wing flaps are a movable part of the wing, normally hinged to the inward trailing edge of each wing. Flaps are extended or retracted by the pilot. Extending the flaps increases the wing camber, wing area sometimes, and angle of attack of the wing. This increases wing lift and also increases induced drag. The increased lift enables the pilot to make steeper approaches to a landing without an increase in airspeed. Their use at recommended settings also provides increased lift under certain takeoff conditions. When the flaps are no longer needed, they can be retracted. Pilots are cautioned to operate the flaps within the airspeed limitations set for the particular airplane being flown. If the speed limitations are exceeded, the increased drag forces created by extending the flaps could result in structural damage to the airplane. The practical effect of the flap is to permit a steeper angle of descent without an increase in airspeed. Extended flaps also permit a slower speed to be used on an approach and landing, thus reducing the distance of the landing roll. Slats. There are two types of slats. The first one, movable portion of leading edge of airfoil, especially wing, which in cruising flight is recessed against main surface and forms part of profile. At high angle of attack, either lifts away under its own aerodynamic load or is driven hydraulically to move forward and down and leave intervening slots. The second one, fixed leading edge portion of airfoil, is a wing or tail plane forming slot ahead of main surface. Both types of slats postpone flow breakaway at high angle of attack and thus delay stall. Ailerons. Lateral control is obtained through the use of ailerons, and on some airplanes the aileron trim tabs. The ailerons are movable surfaces hinged to the outer trailing edge of the wing and attached to the cockpit control column by mechanical linkage. When an aileron is lowered, it increases the curvature of a portion of the wing and thereby increases the angle of attack. Raised ailerons reduce lift on the wing by decreasing the curvature of a portion of the wing and decrease the angle of attack. Elevator. The controls used to give the pilot longitudinal control around the lateral axis are the elevators and the elevator trim tabs. On most airplanes, the elevators are movable control surfaces hinged to the horizontal stabilizer and attached to the control column in the cockpit by mechanical linkage. This allows the pilot to change the angle of attack of the entire horizontal stabilizer. The elevator trim tab is a small auxiliary control surface hinged at the trailing edge of the elevators. The elevator trim tab acts on the elevators, which in turn acts upon the entire airplane. This trim tab is a part of the elevator but may be moved upward or downward independently of the elevator itself. Rudder. Directional control of the airplane is obtained through the use of the rudder. The rudder is a movable surface hinged to the trailing edge of the vertical stabilizer, fin, and attached by mechanical linkage to the rudder pedals located in the cockpit. It should be understood that the purpose of the rudder in flight is to control yaw and not to turn the airplane. Some airplanes are equipped with a rudder trim tab, which reacts in a similar manner on the rudder as does the elevator trim tab on the elevator and the aileron trim tab on the aileron. Stabilizer. Directional stability is accomplished by placing a vertical stabilizer or fin to the rear of the center of gravity on the upper portion of the tail section. Landing gear. The landing gear system supports the airplane during the takeoff run, landing, taxiing, and when parked. These ground operations require that the landing gear be capable of steering, braking, and absorbing shock. A steerable nose gear or tail wheel permits the airplane to be controlled by the pilot throughout all operations while on the ground. Individual brakes installed on each main wheel permit the pilot to use either brake individually as an aid to steering or by applying both brakes simultaneously. The pilot can decelerate or stop the airplane. Hydraulic shock struts or springs are installed in the various types of landing gear systems to absorb the impact of landings or the shock of taxiing over rough ground. There are two basic types of landing gear used on light airplanes. These are the conventional landing gear and the tricycle landing gear. The conventional landing gear, which was used on most airplanes manufactured years ago, is still used on some airplanes designed for operations on rough fields. This landing gear system consists of two main wheels and a tail wheel. Shock absorption is usually provided on the main landing gear by inflated tires and shock absorbers, while it is provided on the tail wheel by a spring assembly to which the tail wheel is bolted. The tail wheel is usually steerable by the rudder pedals. The tricycle landing gear is used on most airplanes produced today. This gear has advantages over the conventional gear because it provides easier ground handling characteristics. The main landing gear is constructed similar to the main landing gear on the conventional system, but is located further rearward on the airplane. The nose gear is usually steerable by the rudder pedals. This permits sharper turns during taxiing. Shock absorption is provided on the nose gear by a shock strut. Some light airplanes are equipped with a retractable landing gear. Retracting the gear reduces the drag and increases the airspeed without additional power. The landing gear normally retracts into the wing or fuselage through the opening which is covered by doors after the gear is retracted. This provides for the unrestricted flow of air across the opening which houses the gear. The retractional extension of the landing gear is accomplished either electrically or hydraulically by landing gear controls from within the cockpit. Warning indicators are usually provided in the cockpit to indicate whether the wheels are extended and locked or retracted. In nearly all retractable landing gear installations, a system is provided for emergency gear extension in the event landing gear mechanism fails to lower the gear. So guys, now I would like you to do some exercises after this information. My dear students, I highly appreciate your attention and I wish you good luck.